Hello guys, welcome to the video. So today we are going to discuss our question flood fill. Flood fill is the first question of our backtracking module and it is also one of the most important question of backtracking. So let's first understand our question. We are given a n cross m matrix filled with numbers 1 and 0. Initially we are standing in the top left corner and we are required to reach our destination that is in the bottom right corner. Okay. Only four movements are allowed to us. What are those four movements? It is either top, left, or down or right. So these four movements are allowed. Now, important part, we can only move when it is 0 present in ourselves. When it is 1 present, 1 denotes obstacle. That means you are not allowed to move when there is 1 present. Okay. Now let's see the sample input and output so that we understand it better. Okay. So this is our sample input that is given to us. Okay, I'll bring it here, enlarge it. Okay, a bit more. Perfect. So we are given this input for n cross m when n is equal to 3 as well as m is equal to 3. Okay, so where are we initially standing? So our source, as we discussed, our source is the top left corner. That means here 0 comma 0. So that's our source. And what is our destination? Our destination is the bottom right corner. So this is our destination. Okay, what are the four movements that is allowed to us? Okay, the four movements was if top, okay, top, left, down, and right. So these are the four movements that is allowed to us. Okay, and I would like to write more things such that if one is present, one means obstacle. Okay, so this is our question. We are just discussing the question first. Now, you must be wondering what we have to print in our output. Perfect. So in our output, first let's discover a path. Okay. So a path can be, if we are standing here, this is our source. So if we move right, then down, then again down and right. So this can be one of our answer. Okay. So how we have to print our answer? We just have to add the direction in which we are moving. In this case, it will be R, right, down, down, and right. Okay. So this is our output format as you can verify here, RDDR. Okay. Now, I suggest you to try this question yourself before moving further to the solution. Okay. Perfect. Now, okay. So here is a n cross m 2D matrix. It's n cross m for 5 is to 5. Okay. So I will put 1 here and we all know what 1 denotes. 1 denotes obstacle. So I will put some 1 here. Okay. Okay. Now let's talk about the empty cells. Okay. So here the empty cells. Okay. Empty cells. So the empty cell denotes 0. And we know when 0 is present, that means we are free to move. Okay. So we are free to move. And what 1 denotes? 1 denotes obstacle. Okay, we know that. Perfect, we know that. Now, all the four movements that were allowed to us. So it was top direction, left direction, down, and right. Perfect. Now, what was our source? Our source was top left corner. So this is our source. This is our source, and bottom right corner. This is our destination. Okay. So initially we are standing here. This is our source. Okay. So here we are. This is our source. We are required to reach our destination and print all the path. Now I want you to think about the movements that is allowed to us. So the 4 movements are allowed to us. So let's talk about the top movement. So if you are standing in a row and a column, okay, if you want to make the top movement, so what exactly will happen? Our row will increase by 1, right? And our column will remain the same. If you take the left movement, our row will remain the same and column will decrease by 1. If you take the down movement, our row will increase by 1 and column will remain the same. If you make the right movement, our row will remain the same and column will increase by 1. So these four movements are allowed to us. Okay. Now, initially we are standing here. I will mark the row and column number. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Initially we are standing here in 0, 0. Now, I want you to see this. Here, if we make the top movement, okay, also always remember that we will always make the movements in this order: top, left, down and right. But why is that? Because our compiler is expecting output in such a way. That's why. So here, if we make the top call, as you can see, if we make the top call, we will get out of the matrix. Okay, our row will get negative and we will eventually access a negative index, and that's worthless. We got out of the matrix. For that, we have to take care of some invalid calls, some invalid movements. Okay, so I will write here what? Invalid calls. Invalid calls mean what is invalid. If that's the case, if it's an invalid calls, then we will not go there. Okay, so 1, if our row gets negative, if we reach a point where our row is negative, or if our row is less than 0, or same, our column gets negative. Okay, I will show you with the help of this. Okay, so if we are standing here, we make the top call, we'll get out of the matrix. Okay, again, if we make the left call, we will again get out of the matrix. So that is not allowed. Okay, what else is not allowed? Okay, I want you to see this. If we are standing here in our last row and we make the down call, so if we make the down call, we'll get out of the matrix in the nth row. So I can simply say if r is equal to n, then also it's invalid. Okay, and again, if we are standing here and we make the right call, the right movement, this time it will also reach out of the matrix. Okay, so I will take care of it, or column is equal to mth column. Okay, if column is equal to m, I will return. Okay, what else condition we have to handle? We know 1 denotes obstacle. So if we are standing at a point, let's say this is an array, if our row and column is equal to 1, then also we will simply return. Perfect. So okay, now we know we have to take care of it. Now again, let's try to make all the movements. So here, first we'll make the top call or the top movement. So our row will decrease by 1, and this time it's part of our invalid calls. So if it is a part of our invalid call, we will simply return this time. Okay, so we'll return. Now the left call, again our column will get negative, so we'll return. Now down call, yes, down call is allowed, so we'll reach here in the first row. Here again, top call not allowed. No, top call is allowed, of course it is allowed. So you get something like you reached bottom, again you will reach top, something like this. Okay, so there's a problem with this. I want to show you the problem. Okay, so stay with me and let's see the problem. Okay, let's understand it with the help of a stack. So for that, I will create a stack. Okay, so this is our stack and our row and column. So initially our row and column was 0, 0. Now, if I will make the top call first, right? I'll make the top call. You have to make calls in this order. So if I make the top call, then my row will get negative and my column will remain the same, and I will simply return because it's an invalid call. Now again, I will return, and now I will try to make the left call, and this time my column will get negative. So if my column gets negative, I will simply return. Now I will make the down call. In the down call, my row will increase by 1 and column will remain the same. That's a fair call. Okay, I will move there. Here again, I will have 4 choices. I will have 4 options. Here again, I will first make the top call, and this time, if I make the top call, my row will get negative. So my row will get 0, 0 again. So this will cause, what this will cause is an infinite loop, and you will eventually face stack overflow. Okay, so that's why you can't visit a same cell again and again. You can't visit a same cell again and again. So how we can handle it? How we can fix the problem? Okay. So what we can do is take a visited array. So what my visited array will do, every time I visit a cell, I will first mark it so that I don't visit it again. So here I already created a 2D array. Okay. So I'll bring it here and I hope it is visible. Yeah. Also, I'll drag our invalid calls here. Perfect. Okay. So what we did, we created a visited array. I will name it visited. And what's the size of our visited array? It's same as our main array, our primary array. So I will assign the row number and column number. So this is our visited boolean array that is storing false and true value. Okay. Now what we are going to do, every time we visit a cell, we are going to mark it true. Okay. And we are going to check if you have visited this array. If you have already visited this array, we are not going to visit it. We are going to simply return. Now let's see what is going to happen. So here I make the top call and that's invalid call. So I will simply return. My row will get negative. Now left call, it is also invalid. My column will get negative. Down call. Okay, before moving downwards, what we have to do this time? We have taken a visited array, and every time we take a movement, we mark true here. So I mark true here first, and then I will take all these movements. Okay. So I am starting at 0, 0. I mark true. Now top call not allowed, invalid. Left call, my column will get negative, not allowed. Down call allowed. So I reached here. So my first step is to mark it visited. And then again top call. And this time, what is going to happen? I will see it is visited, that I have already traveled here. I've already visited here. So in the invalid call, I can write if visited r comma c, rc is equal to true. If you have already visited, then also we will simply return. Okay. So I will return and further explore my call. So left call, my column will get negative, so I will return. Down, yes, it is allowed. I'll mark visited first. Top call, visited. Left call, you will get out of the matrix. Down, yes, allowed. Mark true. Top call, visited. Left call, you will get out of the matrix. Down call, allowed. I'll mark true here. Here. See, top call, visited. Left, your column will get negative. Not allowed. Down call, your row will reach here. Your row will equal to n. So if row is equal to n, that means you are out of the matrix and you will simply return. Now the right call. So this time in the right call, what case will it? As we are standing in an obstacle. If it's 1 in the array, that means we cannot move. So if we cannot move, I will simply return. So as I can see, all the 4 calls got over. We tried all the 4 calls. So after all the 4 calls, I will simply return. But for now, what we will do is after we return, okay, we are also gonna unmark in our visited array. Okay, don't ask why for now, why we are doing it. We will eventually get it. We will eventually understand why we are doing it. Okay, so we'll reach here. We'll finish the pending calls here. The right call, obstacle, 1 is present, so not allowed. You will return and you will also unmark in your visited array. Here, let's see the right call. allowed. So my first step was to mark it true, mark it visited. Here, let's see. Top call 1 not allowed, left call visited not allowed, down call 1 not allowed, right call allowed. So I will mark true here. Okay, here we reach here. So top call allowed, I'll mark true. Top call allowed, I'll mark true. Top call not allowed, because you will get out of the matrix. Your row will get negative. Left call 1 not allowed. Down call visited not allowed. Right call allowed. I'll mark true here. Here, let's see. Top call not allowed. Left call visited not allowed. Down call 1 not allowed. Right call allowed. I'll mark true here. I reach here. Top call, your row will get negative, not allowed. Left call visited, not allowed. Down call allowed. So I will get here. I will mark it true. Top call visited, left call obstacle, not allowed. Down call, yes, it is allowed. I'll mark it true. Top call visited, not allowed. Left call, yes, it is allowed. I will mark it true. Okay, here. Top call obstacle 1 not allowed. Left call visited, not allowed. Down call 1 obstacle not allowed, and right call also visited. So all the calls are finished. So I will simply return, and the next step I will unmark it. Okay, you reach here, you will finish the pending calls now. So the down call, okay, yes, it is allowed. I'll mark it true. Okay, I'll mark it true. And then here again, top call visited, not allowed. Left call obstacle 1 not allowed. Down call, yes, it is allowed. So after the down call, you will eventually reach your destination. Okay, so let's see what does our first destination like. Okay, I'll write 1 here. So our destination is something like, we are initially here in our source, then down. Okay, down, right, right, top, top. Okay, right, right, down, down, down. So this is our first path that we got for reaching from our source to the destination. Perfect. Now let's try to code a bit. Okay, let's try to code it with all the things that we know. Okay, so we are given a function floodfill, okay, in which a maze is passed, a source row, source column, and answer so far. In the answer so far, we will update all the movements that we take. Perfect. So firstly, we know that we need a visited array. So let's create a visited array. Okay. So here you go. A visited array. In my visited array, what I have to append? So I will run it n times. Okay. And you know, in my visited array, I will append false. Okay. And I will run it m times, number of columns. Yeah. So a dot append simply false, right? And visited dot append a. So that's my visited array that will be required to us so that we don't visit a same cell again and again. Fair enough? Now we have passed that floodfill function where initially source row is 0, source column is 0, answer so far empty string. Now we need a visited, as we know. Also, I'm taking an n and m so that I can easily access the last row, and the invalid cases we'll get to know. Okay. So I'll update it here, visited n and m. Now, first, let's talk about the movements that is allowed to us. Okay, the movements. The total 4 movements were allowed to us, so we'll make 4 calls. Floodfill, maze. First, the top wall. In the top wall, our source row will get negative, our source column will remain the same, and in the answer so far, we will simply add top. Alright, and n and m and visited will remain the same. Okay, now let's see the other calls. Now in the next call, that in which the left call. So in the left call, our source column will decrease by 1. Yeah, and in the answer so far, we will add L. Visited will remain the same. Now the third call, the down call. So in the down call, my source row will increase by 1. Answer so far, I will add D. And the last call. In the last call, I mean the right call, we'll move rightwards. In the answer so far, I will add R. Okay, I hope you are understanding this much. We just talked about the 4 movements that is allowed to us. R, top, left, down, and right in this order. Okay, now let's talk about the invalid case. So what is invalid? Okay, so if a row gets negative, if row is less than 0, if source row is less than 0, or source column is less than 0, or we got out of the matrix, it means if source row is equal to nth row, or you can say if source row is equal to n. Okay, or if source column is equal to m. That's why we pass n and m, it will get easier to us. So if that's the case, if we hit any of the condition, we will return. Okay, now we'll have to add more condition here as we discussed. What were those other conditions? That if 1 is present, we know 1 denotes obstacle, or we have already visited this. Okay, so before moving there, before going there, our first step was to mark true in our visited every step we make. So I marked it true. Okay, now let's complete our invalid calls. So or maze srsc, if 1 is present, that means obstacle. So we'll simply return. I'll full screen this. Or we have already visited this. If visited srsc equal to true. If that's the case, then we will return. Now I want you to think when we will get our answer. Okay. So we started in the 0th column of our 0th row, and we know we will get our answer whenever we do our destination. And our destination is the last column of our last row. So I can say if. Okay, first I will write answer here. If source row is equal to n minus 1 and source column is equal to m minus 1, last column of my last row. Now I will print my answer so far and I will return. Okay, so this is the moment when I will get my answer. Okay, now let's continue with the working of our matrix, how we'll explore more paths. Okay, so here we got our first answer. Okay, now we'll complete its pending calls. So we'll make the right call. And if we make the right call, all its calls will finish. So we will simply return. And the other task was to unmark it. So we unmark it. Now here, the right call. So we will get out of the matrix. So we will return and unmark. Again here, the right call. Our column will reach mth column. So we will return and unmark. Here, right call will get out of the matrix. Our column will increase. So return, unmark. Here all the calls are finished. We'll return and unmark. Here also we'll return and unmark. Okay, so now we are in the second column of our first row. Let's see what is gonna happen. Here we are gonna make the left call. We are gonna finish the pending calls, right? So left call, 1 is present, 1 is obstacle. So we will return. Down call, it is visited. Okay, we forgot to unmark it. Okay, fine. Down visited. Right call, 1 is present. So all the calls are finished and there is no path. So you will simply return and unmark. Okay, now that we reached here, important point. You finish the pending call. So the left call, it is visited. Down call, yes, it is allowed to go down. So you will mark it true. You reach here. Top call, visited. Left call, 1, not allowed. Down call, yes, it is allowed. You'll mark it true here. We reach here. Top call, visited. Left call, obstacle, 1. Down call, your row will increase and you will get out of the matrix. Not allowed. Right call, allowed. Mark true here. Here, top call 1 not allowed, left call visited, down call you will get out of the matrix, right call allowed. Also you reached your destination, so you got one more path. So here again I'll print our second path that we got. Let's see how this path looks like. So down, down, right, right, down, down, right, right. So this is our, so this is our second path that we got. Okay, let's continue with this. You must be wondering why we are unmarking, and we are unmarking it. We are unmarking in our visited array. You will understand it. Just stay with me. Okay, so here all the 4 calls are finished. So I will return and unmark. Here also all the 4 calls are finished. I will return and unmark. Here right call is pending, so I'll make the right call, and 1 is present, so I will return because obstacle and unmark. Okay, we reach here in our second row, second column. Now the important movement that we are waiting for. So here we can see one more path here, something like this path. But what I want to show is, what if we never unmarked in our visited array? If we never did so, we could have never explored this path. Why is that? Because let's talk about how we traveled. We traveled something like this. Okay, we went here. Okay, and if we would have never unmarked in our visited array, we could have never gone here because this is visited. We have already visited this. Okay, so that's the reason to explore all the path. If we would have never unmarked it, we would have never be able to go here. So that's the reason we did unmark it. Okay, now right, let's finish pending calls. Now we can go here. I'll mark true here. We reach here. Top call 1 not allowed, left call visited not allowed, down call 1 not allowed, right call allowed. We reach here. Again, you have to move top first because that's how your recursive call works. Okay, you can't simply go down. First call, top call. I get here, I mark it true. Top call, I reach here, I mark it true. It is allowed. Top call, I will get out of the matrix. My row will decrease. Left call allowed. Okay, mark it true. Top call not allowed, invalid. Left call allowed. I'll mark true here. Okay. Top call, I'll get out of the matrix, not allowed. Left call, obstacle 1 not allowed. Down call allowed. I reach here, I mark true. Now here. Top call, it is visited. Left call, it is 1 not allowed. Down call, it is also visited. And right call, 1 is present, that means obstacle. So in that case, what you are going to do? You are going to return and simply unmark. Now you finish the pending calls, right call, not allowed as it is visited. So you are going to return, unmark. If you are going to finish the pending calls, down call 1, right call visited. What you are going to do is return and unmark. Simple as that. You finish the pending calls, down call. Okay. So it is also visited. Right call. You will get out of the matrix. You are going to return and unmark. We are getting very close to our answer. Okay. Here, left call, not allowed 1, down call, visited, not allowed, right call. You will get out of the matrix as your column will increase. So return, unmark. Now you reach here. And this time, you would first make the left call. You are completing the pending calls and it is visited. Now the down call. Yes, it is allowed. You'll mark true here. You reach here. Top call visited, not allowed, left call 1 not allowed, down call allowed. So here you got your one more answer, one more path. Okay, so let's see what our path looks like. Our third path that we got. Okay, so here I will write 3 and our third path is something like okay, so down, down, right, 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 and then down. Okay, so this is the third path that we got. So now if we understood that we are required to unmark our visited array. So here I will unmark it to this time visited SR C is equal to false. I'm simply unmarking it. Okay, because now we know the need why unmarking our array is required. Okay, Now let's complete it and see if we can get more paths or not. Okay. So, okay, here we'll try to make the right call, but it is not allowed. So we will return and unmark. Here also, right call not allowed. We will return and unmark. Now all the 4 calls are finished. So I will return unmark. All the calls are finished. I will return and unmark. All the calls are finished. I will return and unmark. Simple as that. All the calls are finished. I will return and mark. I reach here. The right call is left. I'll make the right call. One is present. One is obstacle. So I'll return and unmark. Here, right call is pending. I'll make the right call, but one is present. So I will return and unmark. So that's how my whole recursion flow will go. Okay. So I think I have write the code. I have completed the code of it. Now let's try running it and see if this works or not. Okay. So let's run it. Accepted. Now let's submit it. Perfect. So that was our question, flood fill. It was a simple question. What we did, we took care of the invalid calls, and we know that only 4 directions are allowed. So we traveled to the whole array. We printed all our path in a format RDD. If we take the right call, we'll mark R. If we took the down call, we'll mark D, and likewise. We also were required to take a visit array so that we don't visit a same cell again and again. We also unmarked our visited array. And here is our code. It was simple code. We took a visited array, our 4 movements that were allowed, invalid calls, and we know when we reach the last column of our last row, we will get our answer. So that's it for this video. If you liked it, do not forget to like, comment, and share. Thanks for watching.